Thank you, guys. So leading, I suppose, quite smoothly into our next guest. So we're talking about how technology integrates into the human body. We'll specifically talk in there about sound. But I've always had an interest in the role that the clothes that we wear, specifically fashion, will play in our future world. Therefore, I'm super excited to welcome our next guest, live from Miami, Florida, Anouk Wipprecht. So imagine a dress that reacts to your thoughts. It turns green when you're happy, when you're meditating. It turns red when you're angry. It interacts with your environment. This is just the tip of the iceberg in the huge potential that brain-computer interfaces will have in our lives and within healthcare. When you hear the word brain-computer interface, you're probably imagining lots of wires and definitely not something aesthetically pleasing. Well, you're in for a big surprise and a treat, because what you're about to see is truly fascinating. So please welcome live from Miami, Florida, Anouk Wipprecht, who will talk to you about her latest creation and some of the work that she has been producing during the last kind of 5-10 years or so. So please welcome Anouk to FutureSound.
Hey everybody, my name is Anouk Wipprecht and thank you so much for introducing me, Jimmy. I have been working in this field for the last 20 years, so from the beginning of 2000. Technology was not as small back then, we had to deal with like big computers, and in my case putting big computers on the body. So I'm really happy in the time and age that we're living right now, of having like really small components that we can in my case put on the body. So I'm combining fashion and technology together. If you want to find out more about me, you can find me on social media if you have any questions after this. I'm doing research around putting technology on the body, and especially I research different sides of that. So, for example, the spaces that we have around us, like the intimate, the personal, the social, and the public space. These spaces all have like measurements. This is the proxemics theory of Edward T. Hall, which I got interested in the half of 2000. And he was basically measuring, noticing that people have a different personal space. And he was measuring those spaces. And those spaces that were depending on like from person to person, emotion to mood, sort of, and also culturally very much. So basically, I take his research into one of my designs, and he was measuring this with a stick, so a wooden stick. And what I do is I measure it with digital servos. So I use ultrasonic rangefinders, for example. This is one of my dresses. So the dress that I have behind me is the spider dress, the robotic spider dress, and it works on these ultrasonic rangefinders. When somebody steps into my the personal space of this dress, then the system is reacting. So their system is attacking. So how you can see that is here, for example, in the next movie. So there are servos built into this dress, and I'm sorry, my dog is barking at the moment as well. The ultrasonic rangefinders are measuring this, and then the system is reacting. Here you can see the system with everything going in the back. Sometimes I like to show the electronics and the pieces, and sometimes I like to hide it. In the case of the spider dress, I really want to show it. Another of my dresses is the sensoric smoke dress. The more people are in the direct surroundings of this dress, the more it starts to smoke, almost putting up a smoke screen, like the ink fish or the octopus, putting out ink and escaping. So that's another of the concept. So in here, the sensors are basically measuring what is around, and the more people that are in the direct surroundings, the more it starts to smoke. So that's the dress in my studio. And last is the robotic cocktail dress. So it's a dress that works with a peristaltic pump, and it was created. It was a collaboration with Cirque Du Soleil in 2015 for their restaurant in Ibiza called Heart Ibiza. So here you can see the system and the peristaltic pump. And here you can see one of the dresses walking around in the restaurant. So basically what I do with my research is basically trying to answer the question, if and when we put technology on the body, what does it do? How can it become social, playful, defensive, behavioral, expressive, emotive, and really seeing fashion as an interface? The reason that I got invited by Jimmy was a little bit to not necessarily talk about music, because I'm myself not a musician. I've been working together with musicians like the Black Eyed Peas, Britney Spears, and more recently Victoria Modesta, who is a bionic pop artist. This is not what the talk is about, because Jimmy thought it was interesting for me to tell you about my work with like neuroscience and body signals, because that might have a cool interpretation for people that are busy with music. You can actually connect your body and brain signals to sound and all of that stuff. So if you look at the body, you can have a lot of places of measurements that you can measure the body, from brain signals, EEG, to EMG, muscle contraction to pulse, EDA, galvanic skin response, respiration. The way we use our lungs is really interesting for emotional data. The heart rate and the heart volume, also accelerometer, so the place and space in your movement. So there's of course a lot of ways that we can measure the body, and all these sensors need to be placed on a certain part. Of course, if you do heart rate sensing, you might want to be close to the heart. So one of my projects that is based on that is Agent Unicorn. It's basically a device that I created at Ars Electronica for children with ADHD. It has a little camera in the horn of the design, and it is a little bit a critic on, if there's something like ADHD in children, we tend to give medicine to the child, sort of, which is dampening their this feeling and their world, sort of, So how can we create instead basically brain-computer interfaces or devices for children that are playful, but that actually are not driven by medication? They might be driven by actually learning these kids how their brain works, So that is a project that is really close to me and really dear to me. And basically, I'm putting a camera in the horn, so the horn is very playful. The kids really like that. And what I wanted to work around is not have the child in a white, in a medical room with a doctor in a white setting and very clean, and that's not super comfortable for the child to be sort of observed like that. But also as a researcher, from my point, the child is not their playful self, because it's constrained by all these things that are going on in the medical setting. So that was one of the ideas to research this and to work on this project. So the device is based on the P3 wave of ERP, event-related potential, in sort of neuroscience, and I'm working with a 1020 system of having these sensors on the head. Normally you have 64 electrodes on the head. I want to close it down to 8 electrodes, and for that it's fitted much better in the headset, which you can see here. So if you're prototyping, it looks like a mess, mostly like this, then you start to build it in, and this was the final device in a museum setting, sort of all smooth and sleek, sort of. But mostly when you're prototyping, it looks like something like this until the final, sort of device. We brought it out as an medical grade, sort of device for makers and enthusiasts that like the brain-computer interface community. It's called Unicorn BI, so you can buy it. And we are also doing workshops with it called brain.io, which is inspired by Agent Unicorn. Due to COVID, it has been happening online a lot. And but you can also, once COVID starts to reduce, hopefully at one point we also will do that in certain places again, so maybe in a city near to you. So Jimmy invited me to talk about this dress. It's the pangolin dress. So it goes into my research on neurotech and combining it with neurofashion. From the 8 electrodes brain-computer interface with the Johannes Kepler University in Linz, and also GTech, a neurotechnology company. we created this dress, and it's actually based on the opposite of the 8 electrodes, closing it down to 8 electrodes. This one is actually driven on 1024 channels, so it has like a really high resolution, so we can measure the brain in a really high resolution, and each of those 1024 points is connected to an actuator in the dress. That can be the movement, or that can be the LED and the animation of that. So so that is what you see here. And I also have a little movie. The whole piece is 3D printed, and there are servo motors and LEDs involved in it. The full movie you can find online. When it went into the press, people said, "Oh yeah, it's a dress that can read minds," which I thought was cool. But yeah, the coolest part is definitely the BCI and the way that we can connect and have a super high resolution. So the pangolin grid system. So the last thing that I wanted to name, because my time is almost over, is open source. So making and sharing with your community, I think is really important for us all to do when you're a creator or a cook, or you have a recipe to share or whatever, you know, because it's just really a nice community that can be stimulated by you sort of as well. So the ways that you can do that is using GitHub. For code, for example, Maker Faire is all about do it yourself and sharing and caring sort of. Thingiverse, if you have like 3D models, you have something laying around. Instructables, from how to make tomato soup to how to make a robotic dress. Hackster.io for hardware hacking, and also the open BCI community is open. Brain computer interface community is really interesting if you like to look more into this notion of EEG and the things that I just told you about. How I do it myself, and I need to do it more on Instructables. A few of my products are really explained on there. So if you want to create, I think, the cocktail dress and some other things. Other things on Hackster.io of the light up kitty ears that I use as a workshop model for children to learn children electronics. So basically in these tutorials, I try to really set up like, this is where you can get this, and this is how you do it almost. That is for free. I don't get money for it. It's just for the community, for people to make these light up kitty ears and learn to solder and learn to work with electronics, and that's just a lot of fun. If you want to get into electronics, working with microcontroller sensors, look into Adafruit Industries. They have small components, also SparkFun from Colorado. Pimaroni is in the UK, if I'm correct. Has a lot of like cool like little kits that you can build with. Also DigiKey Electronics for small components, like Mastercard for anything else. And Arduino is an open source platform board that makes it really easy to code in a derivative of C programming. It has its own programming language, which is pretty simplified. So that's the end of my talk. If you want to get in contact with me, if you want to know more about certain sensors or how to start a certain project, feel free to drop me a message. And I'm gonna give the stage back to Jimmy. And bye-bye.
Thank you so much, Anouk. I have a question. As someone who's clearly living in the future, when do you think technology is used in the pangolin dress with the brain interfaces? When do you think something like that will be kind of in the mainstream, where you'll go into like a store and that will be kind of the norm to buy something like that?
Yeah, I think we're close to there. Sort of, we still need like a little push from the industry. Like one thing is always what I say: washability is the biggest enemy of electronics, right? So how can we wash our garments that are embedded with electronics in a good way? So I know that, for example, the washing machine industry, they have a lot of potential, and they have machines actually developed that wash without water. So that is really good. But those machines are stuck in the laboratory. They're not really available for consumers yet, sort of, you know. And the other big problem that we have is batteries. Batteries are not really created for the body. I don't want to put like lipo batteries on the body yet. I sometimes need that for bigger robotic projects, you know. So I want to have anything lower than 5 volt, but still the batteries that we have are not really created for the body. So how can you work with solar? How can you work with kinetic energy? We all move, sort of, you know. So I think, yeah, sort of some of these ideas and some of these, yeah, products sometimes get stuck by, yeah, the industry not fully ready for it yet. But it's definitely, yeah, the way that we're going using sensors and all of that stuff.
Yeah, it's definitely
And for me, it's really
progressing.
interesting. So.
Yeah.
Yeah.
And one final question before you go. I noticed we had another guest online. What is your dog's name?
Oh yeah, I'm so sorry for that.
No, we were all
Her
laughing
name
in
is
the
Louie.
studio.
Yeah, it's a really small puppy, and she's yeah, she I think the mailman came or something, and she was like yeah, protective. Yeah, I'm actually making a little spider dress for her right now, so if you keep an eye on that, it will be cute.
Looking forward to seeing it. Well, thank you so much for taking the time out and
Yeah.
joining us, and look forward to having you back in FutureSound at some point in the future.
For sure. Thank you
Thank
so
you,
much.
Anouk. Take care. So they say that music connects us. So not only is this the title of our